inverse variation, it is something different. So what is that relation? Like if I say
there's no relation between the other numbers.
Like if there is two variables, x and y. So if x is increasing, the y will decrease. Or you can say if x is decreasing, y will increase. So there is an inverse relation. Like x is inversely proportional to y, right? So here you can see I have given an example. Like suppose if you are traveling a particular distance, let us suppose you are traveling a distance, you're traveling this distance AB, you're moving from A to B. And let us suppose if you have a speed of 50 km per hour, you are taking the time as, let us suppose, 1 hour. Or let us suppose 2 hours. In 2 hours, the speed is 50 km per hour.
So if S increases, T will decrease.
Yeah, so if you are driving at 100 km per hour, obviously the
it'll
time
be 1 hour.
Yeah, it will decrease. So that is like we have the speed and time relation is an inverse relation, provided the distance is same, right? The distance should be same, then we can say speed and time has an inverse relation. So as we had discussed in the direct variation, what we had come to conclusion, x is directly proportional to y, and the ratio of x upon y is equal to constant k, right? This was about direct variation. Now in inverse variation, what we see is x into y is equal to k. Like if we know that x is inversely proportional to y. Now if you have if you have to remove this, you have to put a proportionality constant, right? So x, y is equal to constant k.
Okay, got it. So like in the question you just gave as an example, the k would be 100, right?
Yeah.
Like 50 times 2 is 100, 100 times 1 is 100.
So x into y will be always equal to a constant. Or you can say y is equal to k upon x, right?
Okay.
So if it basically on this we have a law in inverse variation which you must have learned in your school. So what is that? Okay, let us we have got the relation. Now can you say what graph we will be getting if we have an inverse relation?
Like both of them are going opposite ways.
Yeah, like we have this, let us suppose I have drawn a graph for the equation yx is equal to 3 or y is equal to 3 upon x, right? So y and x has an inverse relation, right?
Yeah.
So I have plotted x in the this is x in the x-axis variable, and here we have plotted the y, right? So if x is increasing, what will happen to y? It will decrease.
It'll decrease.
So obviously when x is increasing, the y is decreasing. The y variable is decreasing. Similarly, I have drawn for both, like when x is negative also, you'll find the y will also decrease, right? So the x can have a positive value. For that I have drawn this graph, and if x has a negative value, I have drawn this graph, right? So basically is like if there is a direct variation, what kind of graph do we have for direct variation when x is directly proportional to y?
Basically both of them will be going up.
Yeah, it will be a like straight line, right?
Yeah.
But in case of inverse variation, we have this way, because when x is increasing, y is decreasing. So we don't have a straight line, it is decreasing this way, right? So in inverse variation, we say the two variables have an inverse relation, that is when x is increasing, the y will decrease, or vice versa, right? So there is a rule. What I said is the product rule for inverse variation. Now, what is that product rule? Have you learned in your school?
No. I mean, we have. Sorry. Yeah, we have.
Yeah, the teacher must have taught you this. Like if
x, y is equal to like one number.
Yes.
And like that number will be same for everything in the like other numbers.
Yes. So x1, y1 is one set of variables, x2, y2 another set. So x1 into y1 is equal to k, and x2, y2 will be also equal to k.
Yeah.
Right? Like I'll show you an example later on when we are doing with the problems. So here we find x1, y1 is equal to x2, y2 because both are equal to k. So what you can say, x1 upon x2 is equal to y1 upon y2, right? So this equation, what we have got, x1, y1 is equal to x2, y2. That is known as the product rule for inverse variation, right? So sometimes they can ask you what is the product rule for inverse variation. So we have two sets of variables, x1, y1, x2, y2. So x1, y1 will be equal to x2, y2.